Hello and welcome to this learning video. Now as you have seen that we have taken earlier rule number 1, rule number 2, and in this learning video we are going to take a problem which is a combination of rule 1 and rule 2. As you can see here that the right hand side, that is a function, is nothing but a combination of case 1 and case 2, and it's a plus in between them. So we have applied case 1 and case 2, and we have seen problems separately on those rules. Now we are going to apply rule 1 and rule 2 simultaneously if it is convenient to all of us. Okay, so let us see what this problem says. So this problem says solve d square minus 3d dash plus 2d dash square operating on z equal to this. Okay, so whenever there is a problem of solve, so without any second thought, just find out the complementary function. Okay, so in complementary function we start with what? Yes, given PDE is. If you don't have any time, you can just write given. Okay, so given PDE is this. Then after writing down the given thing, we just need to write its auxiliary equation. So what is its auxiliary equation? Its auxiliary equation is, what is it? Put d is equal to m and d dash equal to 1. So m square minus 3m plus 2 equal to 0. So very easy factors. 2 ones are 2, minus 2 into minus 1 is plus 2, and minus 1 minus 2 is minus 3. So my factors are m minus 2, m minus 1, okay, is equal to 0. So m is equal to 1 and 2. Okay, so once you get the roots, you just write down the complementary function. What are the roots? We have the roots non-repeated. So my complementary function in this case would be phi 1 y plus 1x plus phi 2 y plus 2x. This is nothing but the complementary function. Now what you need to do next is you need to find out pi. So I am highly interested in finding out particular integral, okay, because the right hand side is we have e to power x plus by, where a is 2, b is 1, and sine ax plus by, where a is 1 and b is minus 2. Okay, so what is pi? So pi is 1 upon d square minus 3d d dash plus 2d dash square into e to the power 2x plus y plus sine of x minus 2y. Okay, now just separate. So when you separate this, you'll be getting 1 upon d square minus 3d d dash plus 2d dash square into e to the power 2x plus y plus 1 upon d square minus 3d d dash plus 2d dash square into sine of x minus 2y. Okay, if you are good at applying the rule number 1 and rule number 2 simultaneously, you can do like this only. And if you have a little bit, even a small fraction of confusion, so what you can write is, you can write pi is equal to pi1 plus pi2, where what is this pi1? This pi1 for this and pi2 this. Okay, then you just need to find out pi1 and pi2 separately and substitute over here. Okay, so let us go for finding out pi1. So pi1 is equal to 1 upon, what is pi1? This d square minus 3d d dash plus 2d dash square into e to the power 2x plus y. Simple. And what do you remember what this rule number 1 says? Rule number 1 says put d is equal to a here is 2, and d dash equal to b. So b is invisible here, that is 1. Okay, coefficient of y. So put then, so I have space here, so I can write, put d is equal to 2, d dash is equal to 1 in d square minus 3d d dash plus 2d dash square. We get, what do you get? D square. So 2 square is 4 minus 3 into 2, okay, into 1 plus 2 into 1 square. So this is 3 2s are 6, 4 plus 2 6. So we get 0. Okay, so we get d square minus 3d d dash plus 2d dash square is equal to 0. And we know that if this quantity comes out to be 0, then the case fails. Okay, and once the case fails, then apply the Gayatri mantra. Okay, so just give me a moment. I'm just continuing that. Okay, so here the case fails. So if case fails, then what you need to do is you just need to differentiate or multiply numerator by x, differentiate denominator with respect to d. So what is derivative of d square? That's 2d. What is derivative of this with respect to d? Minus 3 d dash. And what is derivative of this with respect to d? That's 0. So no need to write e to the power 2x plus y. Is it clear? Now we have this, then again you substitute d is equal to 2 and d dash equal to 1. So again you can put, you'll be getting x into 1 upon 2 into 2, 3 into 1 into e to the power 2x plus y. Okay, so what you're getting, you all are getting, this is like x, this is 4 minus 3, 1, x into e to the power 2x plus y. So this is my pi 1. This is my pi 1. Now next you need to find out pi2. So what is pi2? This is my pi2. So come on, find out fast. That's d square minus 3d d dash plus 2 d dash square into sine of x minus 2y. Okay, do you remember? Try to recollect rule number 2. Rule number 2 says put d square is equal to minus of a square. So you can just add one sentence here. Put d square is equal to minus of a square. A is 1 over here, so minus 1. D dash is equal to minus of 1 into minus 2, that's plus 2. And d dash square is equal to minus of b square. So minus of minus 2 square, that's minus 4. Then we get, what we get? This value d square minus 3d d dash plus 2d dash square equal to d square. D square is minus 1 minus 3 into d dash 2 plus 2 d dash square. D dash square is minus 4. Yeah, plus 2 into minus 4. So this comes out to be, what is it? Minus 8 minus 6 minus 1. Okay, so we are getting it to be minus 15, which is a non-zero quantity. So when you are getting the non-zero quantity, feel good, because we don't need to apply anything now onwards. You can directly write down the pi. So here my pi2 is equal to, what is it? Yeah, this value 1 by minus 15. Yeah, minus 8 minus 6 minus 1. Yeah, correct. Into sine of x minus 2y. So this is my pi2. I have got pi1, I got pi2, and we have already found out complementary function. So what you are waiting for then? Just write down the complete solution. The complete solution is what is that? Z is equal to CF plus PI. Okay, where PI stands for PI1 plus PI2. Yeah. So if you want, you can write here also. Equation A implies PI is equal to, what is PI1? This x into e to the power 2x plus y. Okay, and PI2 is 1 by 15 sine x minus 2y. Okay, so you just write down, that is z is equal to phi 1. Do you remember the roots or the complementary function that we have got? So that's 1 and 2. So y plus x plus phi 2 into, factor is 1 into y plus 2x plus what is pi? X e to the power 2x plus y, right? Minus 1 by 15, sine of x minus 2y. Don't forget to write where phi 1 and phi 2 are arbitrary functions. Okay, so this completes the problem on the combination of rule 1 and rule 2. Okay, so I hope this is clear to you. So just go through the lectures on rule number 1, rule number 2, and then only you can solve such problems very systematically, and you can apply the same methods for different types of examples also. Okay, so whenever we are meeting for the next time, so we'll take rule number 3 for particular integral. So thank you for watching this learning video. Enjoy learning mathematics. Thank you.